This introduction. So, as we heard, we come from originally small business. I started Equilibrium Consulting with my partner Eric Karsh over 20 years ago, and we kind of grew from a tiny firm into the firm of around 30 engineers. And then Michael Green developed a relationship with Katerra because of his stardom and exposure. And we were we went along. We also joined Caterra. We kind of drank the Kool-Aid of changing the industry and becoming, you know, the little Silicon Valley people, you know, with the hoodies. And so far, we are having a really good time. We are really enjoying every minute of it. And it opens our eyes to completely different ways of design. So at first we had the talk was called Impact of Business into Digital Transformation, but then we reversed it. So then we said Digital Transformation's Impact on Business, because this actually is that. Like how did my role change? So I just want to give you this kind of journey from where we started. We were always doing projects. We were doing projects with great local architects from Peter Busby and Nick Bevanda and a whole bunch of people in British Columbia and around the world. And then we started working with fabricators, with Structural and with others, and we started going towards the platforms. And so kind of using the same maybe ideas for connections, using the same structural ideas and then configuring it into different geometries. And then with Caterra, we are going into products. And as a structural engineer, I had absolutely no idea about product development. And I still don't know much, but I'm learning a lot. And this is kind of the biggest impact that we've seen of a new role of digital technology on our day-to-day work, is moving from projects to platforms to products. So I'll quickly demonstrate that how things are going. So building platforms. And maybe even before building platforms is that what is Caterra? And you guys probably already know that it's a $4 billion huge Menlo Park-based Silicon Valley startup that is doing a lot of things. In construction, we have fabrication facilities that do prefabricated framing. We just finished building the largest CLT company in the world, 185,000 cubic meters, 20% of European production in Spokane. So very large investments also in technology. In Tracy, there is a beautiful facility, fully computerized, full of robots doing framing, doing prefab trusses, doing prefab walls out of steel studs and wood studs. So a lot of these things. So my role as a timber engineer and a specialist in mass timber is developing the building platforms in mass timber, because this is what I know how to design. And so the platforms are pretty much ideas of certain grids of columns and beam locations that can be then changed into buildings. So what you see here on this slide is that we all know that right now every project, pretty much almost every project, is custom. And this is how our industry always was, and this is to a very large extent how our industry is right now. So with Caterra, we try to build these platforms, and the first platforms that Caterra developed was based not on mass timber, but on steel studs and wood studs, and it was residential. And we call it K3. And it's residential buildings with very aggressive goals, towards the budgets, and very high levels of prefabrication, so walls with mechanical, with electrical, and with everything else. Another one is the garden market, which is the kind of similar, in my mind, development of buildings that are also residential. And so the start was with residential. And this is kind of what I'm doing. I'm now developing a platform for office buildings. So it's a 6-story office buildings, and it is really funny. I just talked to Lucas, and we actually have exactly the same grid. 20 feet of spanning double CLTs, and then 25 feet of spanning the glulam beams. And nobody looked at each other drawings. We just ended up with this because in timber engineering, once you do enough simulations regarding lowering the cost, and just to give you an example, if you have the columns that are too close to each other, obviously the cost is high. And then you go down with the cost somewhere around 20 by 25 feet, the cost hits the bottom. And then when you go towards 30 feet by 30 feet, and we all know that the concrete industry, this is kind of a standard for office buildings, is 30 by 30 and maybe flat concrete slabs. This is what our price will be already higher. So in wood, this is how we based our CLT office platform. We stopped at 6 stories. Why? Because in the United States, you can fully expose CLT beams and columns up to 6 stories. If you go 7, 8, 9, and maybe 7, 8, you can negotiate a little bit if your building facility, building authority is willing to negotiate, but the code actually changes abruptly and says that only 20% of the CLT can be exposed. So why would a private developer pay for CLT if only 20% is exposed? So we just stuck with this with 6 stories. And so this is what we're doing. Now, the whole process of developing a platform is starting to become more of a process of developing a product. So we work with product engineers, we work with product developers mostly from California that used to develop products from technology industry, cell phones, screens, printers, and other materials. And we're learning a lot from them that developing a product is very different from developing a building. So first of all, how a building is different from a product. The building has different soils conditions if you want to repeat it over many locations. It has different loads, snow, wind, earthquake. It has different climates, so it requires different insulation levels. And how is the building similar to a product? The building can be exactly the same geometry. The building can have very similar finishes. The building can have exactly the same entry location, can have the same corridors, which is pretty much geometry. So it is similar and it is different. And it is our challenge right now. So typically when we do buildings, we would use Revit, and architects would work with Revit. Engineers were a little backwards. We would still work with AutoCAD. A lot of details when we have to produce for building permit, we would still do in 2D, and a lot of my colleagues still would do it the same. And we're not that proud of it, but this is kind of where we are. And then there will be a transformation into shop drawings, where in mass timber, they would, excuse me, typically be produced in CADWork, which is a Swiss software. So Western Artrip, Structulam, Katerra, right now, would use this software. And why? Because this is the only software currently right now that actually connects with the CAD/CAM machines. So this is where we are right now. Now, in a product, as you know, they work a lot with CATIA, with 3D experience. So right now, on our project, on the CLT office, we're using a double approach. We're doing first everything in Revit, then into CADWork, then into the files and creating regular shop drawings. And parallel to that, we're doing everything in CATIA. Now, there are issues with, of course, all these softwares. CATIA, it seems to be a wonderful software, and Santiago will go into details why is it easier to model everything in CATIA, but it's hard to find trained people in CATIA. It's expensive to train people in CATIA. It's expensive to pay for business license for a single computer in CATIA 3D experience. So it is limiting the growth of software like this from the pure business sense. But if you actually put everything in CATIA, like we did, for example, for this building, so we started with structure, so beams, columns, CLT slabs, and then every single screw, every single notch, and everything else. Nothing new, all of this can be done in CAD work. But then in CAD work, we couldn't put all the mechanical and electrical and architectural. And in CATIA, we're able to put all of this at the same time. So I know that there are few firms in the world, architectural firms, that are using CATIA, but in our part of the world, it's by all means, it's not popular. We are not, this is not a standard way how we're doing buildings. So why are we using CATIA 3D experience for this? It's easier to generate the bill of materials, which is huge when you do products. So we generate these what we call KPNs, so the numbers for each of the item in the building. In these garden buildings, they just finished generating these numbers. It's over 1,500 numbers, 1,500 different pieces. Every piece has a number, every piece has a price, every piece has a negotiated agreement with the supplier, if it's an outside supplier, or an internal price. It is a lot of work, and you need a lot of help from software to do it like this. So this is one reason why we're using CATIA. And the second reason is that we realize that in many cases, people will not want to have a building which is 120 feet by 240 feet. They will want something a little shorter because the site is shorter, or maybe we have to go with a cross. So because it is all parametric design, it will be relatively easy, that's what our people from CATIA are telling us, to get the shop drawings, to get all the geometry already transferred into something that it's very similar. This is the hope that we have, and this is why we're changing our thinking into designing buildings as products. As the last slide I will talk, and Santiago will continue, is that we're going further than that. We're developing 3D units that are kitchen units and bathroom units that we're already doing for these framing buildings where we're just dropping it, and we're very proud that it's now taking 4 hours to unpack all of this and install a bathroom in a residential building. We're now developing the same thing for mass timber. We're just starting, but that's the plan how to do it. So what our goal is to ultimately change the mass timber office buildings from the projects through the platforms through the products. Santiago is fully trained in software, and he will go deeper in how we're doing that. Go ahead, Santiago.
We've heard the expression before that when we use BIM or when we use Revit, one of its key advantages is that we model or we represent the building the way we're going to build it. But anyone who has used Revit for a meaningful amount of time understand that that's not entirely true because of time constraints and perhaps technological constraints. You're not, as a practitioner, you're not able to represent the building in true fidelity exactly how it's going to be built. And hence the reason for which there's commonly a BIM model by the designers, but then separately the contractor has to make their own model because there's an intellectual divide, a contractual divide, an economical divide, a risk mitigation divide, a divide of every sort between the design work and the execution of the construction. The information that you would require to represent the building as it's going to be built is not available for the most part to the designers. And the design rationale for why the building is designed the way it is not available for the most part to the builders. In Coterra, we have all disciplines under the same roof. And because we have that knowledge under the same roof, now we have the opportunity to implement all that information in an intelligent model. But we are a manufacturer as well. We have manufacturing capabilities. And we would need to represent the building to fabrication level of detail in order for it to truly reflect the way it's going to be built. When we're manufacturing, there are some key considerations that we need to include into the design. Reusability of components is one of them. We want to design a component that we could use in more than one different building type or building platform. We want to consider tolerances. We want to design for manufacturing and assembly. That means we want to reduce the effort for assembly. Anyone who works in manufacturing knows that generally the effort to automate material reduction of a material is much less or simpler than to automate assembly of components. With assembly of components, there's much more orchestration of bringing different components and fastening them together or gluing them together, as opposed to material reduction. The bill of material is a very simple way of encapsulating a broader idea about needing to be able to control operations and continuous improvement of operations and quality assessment, quality control, and continuous process improvements in the execution of manufacturing and site assembly. And we often, instead of trying to characterize all of the things we want to achieve in our supply chain, we simplify it into certain key terms like bill of material. But in order for it to have a bill of material that succeeds in our operational objectives, it needs to contain the right amount of information, and the information needs to be accurate and reliable. When we model with other softwares, we don't have either the mechanism for it to store that information, or we don't have the source of information that's reliable enough for it to function the way it should. The promise with software like CATIA is that we're able to include all of the metrics necessary to make decisions based on manufacturability and cost. This is something that we didn't have that same preoccupation for as designers working solely in architectural disciplines or structural disciplines. The common mantra is they'll figure it out on site. And I've even found myself saying that at one point working in architectural practice. And then I paused for a second. And I thought, what am I doing? I am saying the same thing that I've been criticizing other designers for saying. They'll figure it out on site, and yet I am seeing myself resorting to the same expression because of time constraints. This was before I joined Coterra. Because of time constraints or complexities in terms of how to figure out a condition in terms of construction or design, the pressure forces me to think, I can't deal with this. This is not my responsibility to solve. It's not my scope of work. It's not my risk to mitigate. That happens under the scope of the contractor or the subtrade. This changes entirely in Coterra. You can no longer say they'll figure it out on site. It is everyone's responsibility to figure out the problems that are presented to them as a team effort. So I'm not sure if in this screen, it doesn't really show clearly. No, it shows better here on the projector. With an intelligent model like CATIA, we're able to generate materials, printed materials like exploded views or shop drawings that would enable us to problem solve and present information in a way that some folks are still used to. Frank mentioned in the previous presentation that you're never too large for it to disrupt, and he also said that digital transformation begs the question, what are we transforming into? With a company like Coterra, you would assume that because it's a startup and it's fairly new, you would expect that there is no transformation because the premise is already that we're doing things differently. But that is not entirely true. Many of the people who work in Coterra come from industry. They come from architectural firms. They come from structural firms. And the way they think has an inheritance of how they would practice design in an architectural firm or structural firm. And so there is a transformation that has to happen at the individual level. Each practitioner needs to transition from working with 2D drawings like this and eventually get used to working with a 3D model where you would no longer need a drawing for it to get answers to your questions. Maybe I should stop here because I have a tendency to ramble and take some questions.
Can never undo this thing. So you do have a couple more minutes, but do we have any questions?
Hi, Santi.
Hi, Puyan.
In the process of making the decision to go with CATIA, that's completely changing the platform.
That's a good question. I can't speak for all the voices that have been involved with moving forward with CATIA, but what I'm understanding from other perspectives and ones that I can relate to as well, there are a few key indicators. One is the readiness of the technology. CATIA's, or the 3D Experience platform, is ready to use. You don't need to rewire it. It has maturity that's been proven through the aerospace and automotive industries. And perhaps we need to more learn how to leverage it and not so much modify its core capabilities. Whereas if we're using a suite of products like that of Autodesk, they are not ready for use, and perhaps there's someone that could challenge me on that, but they're not ready for it to use in the way in which the 3D Experience platform is ready for it to deploy in an organization. Another one is the 3D Experience is ready, specifically in the sense that there's no need for it to interchange files, because it comprises a suite of a myriad of different applications that natively interact with the same model. And that resolves a series of technical complications that you've now resolved, and you can focus on simply working on the same model without having to do any sort of translation between departments or disciplines. That simple approach, combined with their cloud implementation of not having to deal with files at all and only data that's stored on the cloud mechanism, it lets everyone focus on the design aspect of their work and simulation and analysis, and they are no longer preoccupied with the details of how do I export this file, where do I export this file, what should I name the file, is this the latest version of the file, etc.
I just want to add to this that there's also an answer from the managerial point of view, and it's availability of people. So we have an office in Montreal, and where we have 4 or 5 CATIA people from other industries. And they are teaching us how it is done in other industries. They already know how to do it. They know more than we're doing right now, how to link it with structural design, with modeling, with when doing it, for example, from aerospace. So this is a huge thing. That we are able to start learning how to do buildings the way they are building planes, and that's a huge leap forward that we can dip into this knowledge.
I just wanted to add this. Brent Mowdy, IBI Group. What I see here and the way you described CATIA is very similar in my past, where I was working with heavy industrial. So working with products from Intergraph or Bentley, and a lot of these tools are spec driven. So when I see that output there, I'm seeing a pure isometric with bill of material, everything come through model as it's meant to be built. In these piping applications, I can't make a 100-meter long pipe. The spec dictates what the material can do, how long the pipe can be spooled, the type of flanges and gaskets, and then the bill of materials makes everything fabrication ready. So I always say, anybody who's using Revit today, imagine if you opened up Revit and you just started to model and you had a whole bunch of prescriptive restrictions that prevented you from replacing certain components, forcing you to think of how it's meant to be built, assembled, fabricated, etc. So the power of CATIA, the power of all these industrial tools, this whole facet of BIM, if you will, that's really not inbred in the Revit workflow or those with Revit familiarity. So just FYI.
Thank you. Great comment.
Excellent.
Anybody else?
Yep.
Hi, it's Annika Chan from Elliston. I just had a question about going from project to product. Does that mean you eliminate the 2D deliverables and you're just producing 3D and that's it?
You can't. You have to go for permit. You,
Damn it.
you have to quickly send the drawings for pricing. You have to communicate all of this. So, but the biggest things is that, you see, we just went through this kind of American style coming up with ideas, and we started looking what is absolutely necessary to build a building. Permit is one of these things that you have to have. You don't have to issue drawings for 25 DD, concept drawings, 75 DD, 95 DD. You don't even have to issue them for 100% construction. No, but by law, you have to get a permit. So there are apparently places in the world where you can start submitting files, but it's not in Canada or United States. So this is one of the things. And also what our CATIA guys are telling us, that it will be easy to generate this. I still have to see it to believe it, but that's what they're saying.
That was going to be my second question. If it's easy to generate, because I've used digital projects in the past and found it very difficult to generate the 2D.
Well, I don't know. Maybe in a year I can answer this question.
One question. You spoke about the structure platform, as I understand it, but I'm more interested to hear about the other dimensions of buildings, such as energy performance and mechanical, specifically like HVAC, and how this fits into that whole vision.
Yeah, so for example, mechanical. You still have to have a mechanical engineer, because we just had this discussion. Can CATIA guys who know enough about mechanical actually put the mechanical system into the building? No, because it has to be designed. It has to be done properly. Just like we, structural engineers, gave them every screw, every notch, every bearing, every thickness of the plate, mechanical engineer has to provide this information as well. But can they actually detail it? All the pipes with everything where the pipe is ends and the new pipe starts and all of this? Yes, they are already doing this. So you still have to have a mechanical, electrical, structural engineer. But these people working with CATIA people can provide this better, they say, model that goes towards the product and the generation of the BOMs and the KPNs. We're still safe as designers, as much as they want to eliminate us.
Hi, it's Derek from ZGF Architects. Can you talk about the clash coordination? How did you manage basically the coordination of what you modeled?
I think it's the clash coordination is exactly the same as it's done in Revit. Like a good Revit model also does beautiful clash coordination. I actually don't see an improvement between clash coordination in a really good Revit model and a CATIA model. For me, CATIA is to change because it's parametric and is generating of these other things, and the model is small, so you don't have to wait, until it's done. But just the clash coordination, the geometric pipes going through my beams or other stuff, it's I don't know, Santi, but I see this as the same way.
Yeah, sorry, my question specifically is, can you talk at very high level about the workflow? So a full round, basically. How do you, start with CATIA and whatever system you use and go back to CATIA to implement the changes?
Well, that's actually a question we have a whole team of CATIA experts in Montreal who have been pulling together this content, and they've done clash detections. I would have to ask them their process, but what from observation, the content is different. So if you have fabrication level of detail in the model, then you can get fabrication level clash detection.